Hello, students. Welcome back. We are into 3.1 homework, and we have had such a good time seeing different systems. I think I'll hit the ones that are typically the hardest for most students, or at least historically, which ones are the hardest for most students. It's the befores and afters. If you look down here at the bottom, usually um, the different number systems from around the world aren't that bad. So I'm just going to say that because, again, I will give you a key. I'll give you the legend. I'll tell you what each one of them is worth. Okay. Um, but usually when we get into different place value systems, that tends to be an issue. Let's see here. Most of these questions are usually pretty good. Which digit has place value hundreds, right? So hundreds, you would find the digit in the hundred, you would say the digit is 5. Write things in the Roman system. So 42, that's a 40 plus 2. So write 40, but I can't write 4 10s. That's not allowed. I have to put 10 in front of 50 and then put 2 on there. So there's 42. So there you go. Let's see here. Place value. Again, place value for the most part in the normal system, people don't seem to have too much of an issue with. This is expanded form. So just remember that every exponent should have its own place value. So 10 to the 6th, there should be a 10 to the 5th and a 10 to the 4th. If they're not there, those are zeros. Then you have a 10 to the 3rd. There should be a 10 to the 2nd. There should be a 10 to the 1st. They're not there. Those should be zeros. So that's why a number like this would be 3004005. And if you want to put the commas in there, that's where they would be. 3,004,005. Okay. You'll see some that say write it in words. So again, find the place values, write that in words. We write in groups of 3. So when you write something like this, you would say 56 and then give the place value. In this case, it would be million. So 56 million. Next group of 3, 283. What's the overarching chunk? Thousands. So 283,000. And the last group of 3 is just ones. So we would just say 914. Okay. Very, very, very good to have that skill. We need to be able to kind of speak, at least in our number system. What else do we have? What are the first 15 counting numbers? That's a good exercise. And it's so hard to say it, isn't it? I know it is. I know. I know it is, but you got to try it. You can do it. So if we were in base 4, I'm regrouping by 4. Every time I get to 4, I never write a 4. I just regroup. So for base 4, the only digits I can use are 0, 1, 2, and 3. So if I was counting, I would count 1, 2, 3, 4, 5, 6, 7, 8. And remember, all of these have the little 4 there. I'm not writing all of them down because I'm trying to work my way through it here. But so 2, 0, base 4 would mean 2 groups of 4 and 0 ones. This is the number 8. That's why I said 8 with it. Next up would be 9. There's 9. There's 10, 11, and 12. So again, you notice I just keep writing the digit 2 until this one hits the ding, ding, ding mark, and then it regroups to a new column and restarts. Okay, what is this? This is 3 groups of 4. What is 3 groups of 4? It's 12. So that's 12 in our system. So that's 12. 13, 14, 15, and they said stop at the first 15. That's great. I'm going to keep going. So I was at 3, 3, so that's 12, 15. This is 16. I want to write it this way, but no, I can't write the 4. I have to regroup it. That would be a 0. This would be a 4, but I can't write the 4, so I have to regroup it. And that would be my next place value after 3, 3. It's a little hard for students at times. If you need to, come over and write out the place values. For base 4, I'd have 1s, then 4s, then 16s. Again, 4 times 4. If you did 16 times 4, you'd get 64. That would be your next place value. Okay. So that's why when I write 1, 0, 0, it means one group of 16, no 4s and no 1s. It looks like 100. It's not 100 because we're living in Forsylvania. or something like that. Okay. So there we go. How many different digits are needed for base 20? If you made a base 20, how many digits would you need? Let's see here. What is probably the toughest one? Ooh, probably the toughest ones are like down here. What's before and after a certain number? Okay, so this is see this one 555 base 6. So 555 base 6. So right before that would be 554 base 6. Well, that's not too bad. And the one after that would be 556 base 6, except a 6 doesn't have this symbol. So that would be a 0 and a regroup. But 5 and 1 would be 6. Again, I can't write that. So that's a regroup. This would be a 6, which would be a regroup. And we would end up with 1000 base 6. Okay, there we go. Now, for some of you, you're going to be like, what and why? If you're struggling with this, that also probably means that you really never learned the why for writing in base 10. When you deal with your students and your students get up to writing 8, then 9, and then you write 10, which is 10, might feel good with that. But then you come down to 18, 19, and you say 20, and they write this. And you have to be able to understand why they're having an issue with it. It's the same issue that you might be having with the different number bases. We are regrouping and trading. And even if you get that one marked down, by the time you get to 9, in base 10, for you, it's so quick to see what comes next, but not because you're thinking about it. It's just because you have experience with it. So yes, I will be doing most of the exam questions with different number bases because I need you to be in a position like your students will be, where they're trying to understand place value in depth. Oh, let's see here. What else? What's wrong with the following digits? Hopefully you can pick some of them out as I've kind of dropped a few hints. What else? Find B if possible. Oh, so these are somewhere you have to do a little bit of maybe a little bit of algebra, but not a ton of algebra. It's more of understanding that this B is groups of 7. So how many 7s plus 2 get me to 44? And then if you kind of take 2 away, it's really how many groups of 7 is equal to 42. So how many groups of 7 does it take? Well, it takes 6. And so this would actually be the numeral 62. Base 7 is equal to the number 44. Okay. So if you had to convert from base 5 to base 7, I would recommend that you take base 5, go back to base 10 first. That's my recommendation. And then go over to base 7. Maybe let's do one of those and then we'll probably call it a day for this section. Why don't I throw one of those out here? Okay, so here we go. We're going to turn 423 base 5. We are going to turn it into base 7. That's what I want. I want it to go to base 7. So 423 base 5. At the end, I really want to know what is this in base 7. Okay, the problem is I don't know how to do that directly. So what we're going to do first, we're going to put it back into something we know a little bit more with, and that is base 10. So 4 groups of, this is 1s, these are 5s, and these are 25. So 4 groups of 25 plus 5 groups of 2, or 2 groups of 5 plus 3 groups of 1. So this becomes 100, this becomes 10, this becomes 3. So I get 113. Okay. And that is again base 10. If I don't write anything, it's base 10. Now I need to turn this into base 7. So think about base 7. Base 7 is going to have place values of 1, 7, 49, and the next one up would be 343. But this number doesn't have enough of those, so we won't get that far. We'll get up into the 49. So I can clearly see I have at least one 49. Looks like I have 2 groups of 49. Okay, so I need 49 times 2, which becomes 98. Got it. So now do 113 and take off the 98 that you just used. And that's going to give you a 5 right there. That would have been 20, but it's not, so I get 15. Now take 15. How many 7s can you make out of 15? Well, let's see here. 15 as a 7, another 7. 7 times 2 would be 14. Okay, so 2 of them will work. So I'll take away 14. So that's 2 of those, and 14 would have 1 remaining. So I would write this as 2, 2, 1, base 7. Okay. That's how we do it. If you wanted to turn this into base 2, you could absolutely turn the number, what is it, 113 into base 2. You just have to do base 2 instead. So base 2 is not going to be 1s, 7s, and so forth. It's going to be 1s. If you remember what I did with my fingers, I have 1s, then I have 2s, then I have 4s, then I have 8s, then I have 16, then I have 32, then I have 64. I'm going to keep going until I get past this number, which is 128. Okay, so my 128s are out, so don't need those. But 64s, I have a 64 there. Okay, so here in the middle, I need to then get rid of this stuff and say, what would I do? I would do 113 minus 64. Okay, well, minus 63 would be 50. So this would be 49 left over. So now 49, how many 32s? I do have a 32. So 49 minus 32 gives me 17. Okay, 17. What is 17? That's a group of 16. No 8s, no 4s, no 2s, and a 1. So I can kind of think about that and say, got it. So it's also the same thing as writing 1110001 base 2. It's the same thing because all we're doing is counting groupings. Okay. Some students, it's helpful to picture something. If you want to, you can picture this with poker chips. Think about poker chips. So here's your white chips, here's your red chips, here's your black, right? Here's your teal, here's your pink, here's your blue. I didn't do blue yet, okay? And you just think about those. Every time I play a poker chip, it has a value. So if I wanted $113 in this casino, they would give me one chip that's worth $64, one chip that's worth $32, one chip that's worth $16. And when I get done with that, if you think about that, that's 64 plus 16 plus 32. Let's see, that's 60, 70, that's 80. Plus this gives me 112. So basically those 3 chips gave me $112 worth of value. But I needed 113, so they come over and they give me $1 chip, and I'm good. So you can absolutely think about these. Or if you have poker chips around your house, you can actually play them out and see how they trade in for equal value. I think that should do it because the next one's 3.1. Okay. Well, that's it for this one on the homework. And I hope everything's going well for all of you. I'll see you soon. All right, off you go.